grade 8s, today we're going to look at creating equations from word problems. So to start, we're going to take a look at an example that we'd looked at previously. A pizza costs $8 plus $2 per topping. To make an equation, I could make a table of values, and so let's review how to do that. Here's my table of values. I start at $8, $10, $12, $14, $16, depending on the number of toppings. So to make the equation, I would need to look at what is that cost going up by each time. And if we look, it's going up by 2 each time. Once I know that it's going up by 2, I take all of my input values, all of my number of toppings, and I times them by that number. So I'm going to do 0 times 2 is 0, 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, and 4 times 2 is 8. Then I want to look at those numbers that I got and take a look at the cost numbers that I'm trying to get. So what do I need to do to a 0 to make it an 8? I need to add 8. What do I need to do to a 2 to make it a 10? I need to add 8. And this will work all the way down for those other numbers as well. So I have found that they go up by 2, and I need to add 8 each time to make this equation work. Your number that it goes up by each time, 2, that's going to give you your coefficient. And the number that you're adding or subtracting each time will give you your constant. And once you have those two numbers, you can go ahead and make your equation. So cost will equal 2 times the number of toppings plus 8. And that's how we can make an equation from a table of values. What we want to look at today is there an easier way? Can you skip the table of values? And you can. So let's take a look at how to do that. Let's scrap our table of values. And let's take a look at our equation again. C equals 2t plus 8. And if I look at the problem, a pizza costs $8 plus $2 per topping. And you'll notice that there's an 8 and a 2 in the question, and there's an 8 and a 2 in our equation. So what this is telling you is that the question is really giving you all the information you need without having to do the table of values. So every time we have a word problem, we're going to look for two numbers. We're going to look for what is the initial value and what is the rate of change. And so on this example, what is the starting cost of a pizza? The starting cost of the pizza is $8. That's our initial value. And what is our rate of change? Well, that cost goes up by 2 every time we add a topping. So my rate of change is 2. My initial value will always be my constant, and my rate of change will always be my coefficient. And once we know that, we can put them right into our equation because we know that the coefficient is the number in front of the letter, right, in front of the variable, and that the constant is the letter at the end, the number at the end that we add or subtract. So let's look at a new example and see if we can do this one without a table of values. A bike rental company charges $20 plus $3 per hour. Write an equation to represent the cost of the rental. So because we're not doing a table of values, we do want to start off by identifying our variables. What are the two letters we're going to be using? They're asking us to find the cost of the rental. So one of our variables is going to be C for cost. And the cost depends on the number of hours. So the number of hours is our second variable. So we're going to use H to represent the number of hours. Now we just need to find what is the initial value and what's the rate of change. So what is the starting price here? The bike rental company charges $20 plus $3 per hour. So my initial value is 20. And the rate of change, what is that going to go up by each time? It's going to go up by 3 each time. So we can make our equation from this. The cost is our output. It depends on the number of hours. 20 is our constant and 3 is our coefficient. So cost equals 3 times the number of hours plus 20. And there's your equation. We don't have to do a table of values, but let's just check our answer with the table of values to make sure that it works. So if I use my equation to see the price of the rental for 1 hour, 2 hours, 3 hours, or 4 hours, if I use my equation, 3 times the number of hours plus 20. 3 times 1 plus 20 is 23. 3 times 2 plus 20 is 26. 3 times 3 plus 20 is 29. 3 times 4 plus 20 is 32. So I want to just look and see if those numbers are reasonable. So for 1 hour, does it make sense that the cost would be $23? $20 for the initial plus $3 for the 1 hour? That makes sense. Let's look at 2 hours. $20 for the first hour plus another $3 plus another $3. That works out to 26. So it looks like our equation is right. A new example, a taxi charges a flat fee of $5 plus $1 per kilometer driven. Write an equation that represents the cost of the taxi ride. So again, let's find our variables, our initial value, and our rate of change. They're asking us to find the cost, so C is going to equal the cost, and the cost depends on the number of kilometers we drive. So we're going to use K to represent the number of kilometers we drive. Our initial value, what is this cost starting at? It's starting at $5. And our rate of change, what is it going up by per kilometer? It's going up by 1 per kilometer. So we can take that and write our equation. Cost equals 1 times the number of kilometers driven plus 5. This one's a bit of a special case because we have 1 as a coefficient. We don't actually need to write the 1, so you could write this equation as C equals K plus 5. The number of kilometers driven plus 5. William works at Starbucks and gets paid $16 per hour. Write an equation that represents the relationship between the number of hours worked and his total pay. So our variables here, they're asking us to look at his total pay. So we're going to use P equals total pay. And his pay depends on the number of hours he works. So H is going to equal the number of hours he works. The starting value, our initial value here, is 0. If he works no hours, he does not get paid anything. And the rate of change, what is this going up by each hour? It's going up by 16 each hour. So the total pay equals 16 times the number of hours plus 0. We don't need to write plus 0 because that's not going to change anything, so we can just leave it as 16 each. It's your turn to try this now, so I'd like you to do is pause the video here, try to get the answers to these 4 questions, and then when you're done, come back and I'll go through the answers with you. Okay, so hopefully you've had time to go through these equations on your own. What you wanted to find in each of them is what is that initial value and what is your rate of change. So if we look at the first one, a tow truck company charges a flat fee of $50, that's your constant, plus $75 per hour. So 75 is your coefficient. So cost equals 75 times the number of hours plus 50. The next one, the water level in a pool is 6 feet and it is draining at a rate of 1 foot per hour. Our starting value here was 6, and this one was a little bit different because it was going down 1 each hour. So we need to make sure our coefficient is a -1 because it's going down. So the water level will equal -1 times the number of hours plus 6. Sarah earns $20 per hour to work at the restaurant. Our initial value here was 0, and the rate of change is 20. So the total pay equals 20 times the number of hours. A water tank already contains 55 liters of water when Baxter begins to fill it. Water flows into the tank at a rate of 8 liters per minute. We are starting with 55 liters, so 55 is our constant, and it was going up by 8 every minute. So the water level equals 8 times the number of minutes plus 55. Hopefully you have a good idea now of how to create equations straight from those word problems. So go ahead and try your work for the week and make sure you visit office hours with your teacher if you have any questions. Have a good week, grade 8s.